Well, hey guys, you're probably Mr. Roden here. You're probably wondering why you're watching a video today and not listening to live action Roden like yesterday. But what I did is yesterday I pulled my best and brightest students in eighth period, and I let them decide what they wanted me to do for the lesson today. And then I asked them, and the eighth period statistics turned out like this: 57% of the students in eighth period said they liked live action Roden the best, and 62% of the students liked video Roden most. So we're going to go with slightly higher score for video Roden over live action Roden. So we're going to use video today. I'll pull them again tonight and see what eighth period wants to do tomorrow. And so either I'll do live action or video based upon how my eighth period votes tomorrow. They might change their mind or whatever. Sometimes they like doing different things on different days. Okay, so today what we're going to do is we're going to do lesson 1.3. And so each day what's happening is we are getting a little more complicated in our equation solving, but it's stuff we've done before. So let's go ahead and get going. And there will be a secret code in this video, and you never know where Mr. Roden is going to tell you when the secret code is. And he never writes it, so make sure you are listening carefully for the secret code. All right, so on this one right here, the first thing I want to do, number one, is I want to attack the weaker variable. I like to get the weaker variable to go away. Now, I'm looking on both sides, and actually negative 10 is the weaker variable. Negative 10 is weaker than negative 6 because negative 10 is more negative than negative 6. So how do we get rid of a negative 10? Well, yeah, we just add 10x to both sides. We add 10x to both sides. If you have negative 10x and you add 10x, those cancel out to 0. Now, negative 6x plus 10x, negative 6 plus positive 10 is positive 4x. So we have 4x minus 4 equals negative 16. Now we're going to solve this just like a two-step equation. So we're going to add 4 to both sides. We're going to add 4 to both sides. Again, a lot of you are struggling with this whole negative positive concept. Negative 16 is negative, 4 is positive. So we're going to subtract and keep the bigger number. Well, 16 minus 4 is equal to 12, and the negative is bigger, so it's going to be negative 12. So we get 4x equals negative 12, and then what we're going to do after that is we're going to divide both sides by 4, and we get x equals a negative divided by a positive is a negative, and 12 divided by 4 is negative 3. So our answer for number 1 is x equals negative 3. Okay? All right, let's try the next one. So for number 2, same kind of thing here. So now on number 2, I'll put my fairness bar, and I'm going to attack the weaker variable. Well, which one's weaker, 7x or 9x? Well, obviously 7x is less than 9x, so we're going to attack it. We're going to make it go away to 0. So I'm going to subtract 7x's from both sides. 7x minus 7x cancels out, and that becomes just negative 7. So negative 7, 9x minus 7x is 2x minus 23. Okay, so now we're going to get rid of the negative 23 by adding 23 to both sides. We're going to add 23 to both sides. So those cancel out like that. So now I'm going to go over here, and I've got my negative positive chart. I always like to do this so I just don't mess up my negative here. And so my negative is 7 is negative, and 23 is positive. So I'm going to go ahead and I'm going to subtract them because they're on different sides of the chart here. So 23 minus 7. Well, what's 23 minus 7? I believe 23 minus 7, if I do my math right, is 16. And since the bigger one is positive, it's going to be a positive 16. So now what I have, what do I have here? I have positive 16 equals 2x. And then I'm going to divide both sides by 2. And then I get x equals 16 divided by 2, which is 8. I think I'm going to go ahead and give the secret code a little early today. So the secret code is, I'm not ready to give the secret code yet. I'm going to give it earlier, but I'm not yet ready yet. I just don't feel like I'm ready to give a secret code quite yet, but I'm starting to think, hey, what's a good secret code I could give everyone? So pay attention, because you never know when the secret code is going to come. All right, so let's go ahead and do this problem right here. So this one, if I remember right, this is number 3. All right, now you go ahead and do number 3 and see what you get, okay? All right, so hopefully you actually tried number 3 and not just copied down my work. So because it's always better to try it first and see if you get it correct and see if you get a green check. Remember, green checks, we go, hey, green check. Hey, when we get that green check, those are always good. You know what we don't like is red X's. Red X's are no, we don't want those, okay? We want green checks. That's what we're looking for, people, on this Delta Math, green checks, right? Okay, so here we go. So the next thing I'm going to do, my phone is ringing, but it was spam, so it doesn't matter. So I'm going to attack the weaker variable. So hopefully you subtracted 2x from both sides, subtracted 2x from both sides. So the 2x's cancel, and now I get 9 equals 7x minus 2x. Well, I think that's 5x if I do my math right, minus 26. Now I want to get rid of this minus 26 by just adding 26 to both sides, adding 26 to both sides. So what is 26 plus 9? Well, I think that is 35 if I did my math right. Hopefully I did. And then I get 5x equals 35. Is that what you got? And then you just simply divide both sides by 5, and 35 divided by 5 is 7. So I get x equals 7. All right, hopefully you got that one all by yourself and you didn't just copy down. Did you give yourself an imaginary green check if that happened? All right, excellent. I'm kind of feeling like a good secret code time, but not yet. Okay, I think I need to do another problem. So this is what number? This is number 4. Okay, so let's go ahead and do number 4 really quick. Go ahead and do number 4 on your own and see if you get an imaginary or green check. Hopefully you don't get an imaginary red X. That would be bad, right? Okay, so the next thing, I'm going to attack the weaker variable. I like to attack weaker variables. That's how Mr. Roden likes to do that. So I'm going to get rid of that 9x first because it's weaker than negative 7x. Negative 9x is more negative than negative 7x. How do I get rid of a negative 9x? Yeah, I simply just add 9x's to both sides. I add 9x's to both sides. Now, if you have negative 7x and you add positive 9x, really you're going to subtract and keep the bigger one if we did a chart, right? So that would mean that this is going to be 2x. So negative 7x plus 9x gives me 2x. I still have the plus 6. And then over here, don't forget that negative that's with that 2 right there. You have that negative 2 right there, okay? All right, so now we'll subtract 6 from both sides. We'll subtract 6 from both sides. And then we have 2x equals, now this one's interesting. Now I'm going to give you the secret code right now. I'm going to kind of sneak it in here. The secret code is attack the weaker variable. Please write that next to your name, attack the weaker variable. The secret code is attack the weaker variable. Okay, so now the next thing we're going to do is we're going to take negative 2 and negative 6. Negative 2 and negative 6 is okay, so 2 is negative and 6 is negative. So 2 and 6 are negative, so we're going to go ahead and add them and keep the sign on top because they're on the same side. Well, 6 plus 2 is 8, and it's negative, so this is going to be negative 8. So now we have 2x, 2 divided by 2, so we get x equals a negative divided by a positive is a negative, and 8 divided by 2 is 4. So I'm getting negative 4. Hopefully I'm not making any mistakes on these. That would be terrible. All right, next problem. Now, I copied this from Delta Math. These look a little different. So what's going to happen, and this is number 5, so this is kind of on the back of your work right now. Number 5, these are some weird things that could happen. And we kind of talked about these, but I think practicing this is really good. So the first thing I'm going to do is just kind of forget about this for a second. So I'm going to put a fairness bar, and and then what I'm going to do is, the first thing I'm going to do is I'm going to do distributive property. Okay, so when I do the distributive property, let me just write that answer down here. I'm going to have negative times a negative is positive. So that's positive 20x. That looks like a weird positive. Let me clean that up a little bit. It's a positive 20x. And then a negative 5 times negative 5 is positive 25 equals, okay, so now we have negative 4 times a negative 5. That is a positive 20x. And negative 4 times negative 6 is positive 24. Positive 24. You fix that. So now we have a positive 24. Now, just like we had before on the front part of our paper, is we attack the weaker variable. But it's a tie. They're both the same strength, right? So we'll just attack one of them, and then we'll just subtract the other one off. Now, what happens here, guys? 20x cancels 20x on both sides. Now, what are you left with? You are left with a 25 on the left side and a 24 on the right side. Is that a true statement? Is 25 equal to 24? Well, no, those aren't equal numbers. So what you would do is you'd click on you'd click on this little arrow down here, and you get a table, and you want to write no solution. You'd click on no solution, and then you're done. Okay? So you would click on the one that says no solution, because 25 does not equal 24. So this would be a no solution example. Okay, let's do another one. All right, so here's the next one. So again, I'll just do this. So I'm going to do the distributive property. So negative 7 times positive 7 is negative 49. My bad. Sorry, it's negative 49x. 7 times negative 1 is negative 7 equals negative 5 times 5 is negative 25x. And then negative 5 times negative 8 is a positive 5 times 8 is 40, I believe, right? Okay, so let's attack the weaker variable. Which one's weaker? Well, negative 49x is weaker than 25x. So we're going to we're going to add a 49x to both sides. Okay, let me go ahead and do a chart over here. And I'm not going to worry about the x's. So I've got my negative, then I got my positive. I got 25 that's negative, right? And then I've got 49 that's positive. So what I'm going to do is I'm going to subtract, because they're on different sides. I'm going to subtract. So I have 49 minus 25. And I do the math. Well, 9 minus 5, what's that? 9 minus 5 is 4, I believe, right? And then 4 minus 2 is, 4 minus 2 is, that's 4 minus 2 is 2, right? Now it's going to be a positive 24 because 49 was bigger than 25. So what do we have here? So this becomes negative 7 here and equals, let's see here. What do we get here? We get 24. Sorry here. 24x, because there was an x with that, plus 40. Okay? So the next thing I'm going to do is I'm going to get rid of the 40 I'm going to subtract 40 from both sides. I'm going to subtract 40 from both sides. So 40s cancel. A negative 7 minus 40. Now we're getting more negatives. Think about our chart here. On our negative positive chart, we're at 7 negative. We're at 40 negative. That's going to be 47 negative because it's on the same side. So this is negative 47 equals 24x. All right, so now let's see if those two actually go into each other there. So, by the way, now we're going to divide both sides by 24 and divide both sides by 24. So 47 divided by 24 equals, now it didn't go in perfectly. So, hopefully I did everything right here, because usually we get a nice answer. So if I did something wrong, I might have made a mistake. Can you find my mistake? I'm getting negative 47 over 24 for my answer. We'll see if that's correct. That would mean I would click here and I would get one solution. Hopefully I did it right. And then I'd click on the next one and write negative 47 over 24 as the answer. I'm not feeling, I don't want to spend forever on the video. Maybe you can correct it. I'll give you some jag bucks if you see if I made a mistake here. I don't know if I did. Maybe it's just a weird answer, but if you can figure out my answer and show it to me, yeah, I might give you some jag bucks for that. Sound good? Awesome. Okay, hopefully I don't make the same mistake. I'm going to go really slow here. So this one, I'm going to do the distributive property on this side. So I'm going to get negative 4x minus 8 equals negative 4x minus 8. Now already I'm kind of seeing this is kind of weird, right? Well, when I I can add 4x's to both sides. So when I add 4x's to both sides, the 4x's cancel. And so I get negative 8 on the left side and I get negative 8 on the right side. Is that true? Is negative 8 always equal to negative 8? Yes, negative 8 is equal to negative 8. So that's true. So what we're going to do is we're going to click on that, and that means there's going to be infinite solutions. Infinite solutions. Okay, I think that's what it should say when you click on that, and you're done. Okay, let's keep going. What number are we on here? That was this was number 6. Number 6 is the one I feel a little worried about, right? And then number 7 we just did. I feel pretty good about number 7. That looks like infinite solutions. All right, last one. Try number 8 on your own right here and see what you get. Okay, go ahead and try number 8. All right, let's see how you did on number 8. So when we do the distributive property, 7 times 6 is 42, and a positive times a negative is a negative. So we get negative 42x plus 7 times 1 is 7 equals 6 times negative 1. Remember, there's a spooky one right here, is negative 6x, and 6 times negative 1 is negative 6. So I did the distributed property on both sides. Let's make sure everything looks good. All right, so the next thing I'm going to do is I'm going to attack the weaker variable. So I'm going to add a 42x from both sides. I'm going to add a 42x from both sides. Make my little chart over here, negative, positive. I have a negative 6 and a positive 42. So I'm going to subtract and keep the bigger sign, which is going to be positive. So 42 minus 6, let's see here, 42 minus 6, I believe is, let's see here, so 6 is 2 and 4 more. So we could go down to 40 and then 40. So I'm thinking we're getting 36 here, right? Is that right? Okay. All right. So now we get, and that should be it's going to be a positive because the bigger one's positive. So it's positive 36. So now we get 7 equals 36x minus 6, right? Okay. All right. I think I've done everything correct there. So now I'm going to add a 6 to both sides. I'm adding a 6 to both sides, and now I get 7 plus 6, I believe, is 13, if I did my math right. 13 equals 36x. And then I'm going to divide both sides by 36. Both sides by 36. Now, I don't believe 13 is divisible by 36. I think those are not divisible. So they are not divisible. So I'm feeling actually maybe a little better about number 6 because it looks like these are getting really kind of funky answers. So I'm coming up, and I think I did all my math right. If I did it wrong 2 times on 6 and 8, I'd feel pretty bad. So I'm not going to go back over it. But if this truly is the answer, 13 over 36, that means there's one solution. Okay, so nothing weird happens. So we're going to click on this and write one solution. And my guess is if there's one solution, if I remember this right, you're going to click on another one and you'd actually put the answer of 13 over 36 into the answer bar and you'd be done. And that's it, guys. Now your job is to get on to Delta Math and do your 1.3 Delta Math assignment, and that is due this coming Monday. Make sure you have the secret code. I said it very fast in one of the problems, so you have to go back and figure out where the secret code is. And you don't get any credit if you don't for this paper if you don't do the secret code. See you later. Have a good day. Bye.